So what we got cracking here, Ads?
Well, basically we've taken the pinion flange off the diff and we're going to adapt the tail shaft. So we had an entire four-wheel drive tail shaft with the unis and stuff like that, but we cut it because it's going to be too long. I did think about machining an adapter and a spacer to adapt the original pinion flange on the unis to the new stuff. So I cut it off and machined this down, and I was going to make a step that adapted onto here and stepped up to the new tail shaft, but it's actually got non-rebuildable unis in the tail shaft, and they're terrible condition as well. So that should flop over like that one. So it needs to be fixed anyway. So we're just going to go to a bigger setup with replaceable unis, and the best way to do that is to adapt the pinion flange to accept this spigot. So you can see the spigot on here, this is 44mm and this one's 50mm. So what I'm going to do, I've chucked it in the trusty Optimum lathe, the Hair and Ford special, and I'm just going to machine out the pinion flange so that this shoulder sits hub-centric on the pinion flange, and then we're just going to re-drill the holes. Easy as that. Yeah, and then we get a big tail shaft with big unis, and you know, it'll be strong and hub-centric. It'll be really, really well done. So beats doing this, which will make our life harder later on. So we may as well make it better for us while we've got the chance. Alright, so theoretically I've just taken this to the same size as this shoulder of this. So here's the moment of truth. Oh, nice. Really nice. There's another one, there we go. Auto punch. Alright, hi and welcome back to the shed, where we're currently been smashing out on the MX5, the MX400 as we've come to call it. So we've got him up on the lift here in the other part of the shed, and I just want to do a quick progress report instead of running through one of these big massive montages like we have been every session. I'm just going to let you know where it's at and what we've completed. Basically, engine mounts, wherever they are, up here, those guys are done. So engine's mounted. As far as the gearbox goes, we've got a gearbox mount here, but I'm actually not very happy with it. I'm really want to redo part of it, because if you see this up here, we've got to get exhaust all the way there, all the way through here. And if you have a quick look at the way that lines up, then it's not really the greatest. If I wanted to put, well, we are going to put a 3-inch pipe through there, then it's not really work too well. So what I'm going to need to do is do some extra modifications to that and make it work how I sort of really want it to work. Which is basically going to involve making a piece that does a little bit of a loop. I did play around with the idea of lowering the cross member and then putting standoffs on there and things like that, but I think this is going to be the best thing to work with, because it's very simple, and the higher the cross member is, the more ground clearance we're going to have at the same time. So we've also got our diff sort of back in. Our pinion flange here has received quite a lot of modification. So you can see now there's 2 sets of holes in the pinion flange. Usually there's only 4 holes, but now we've got 8 holes. So we've gone with using the heavier duty tail shafts ends that we got. I think the tail shaft is out of a 300ZX, and it suits that box because that gearbox is 300ZX. And we wanted to go with the larger unis because basically they're stronger and rebuildable, whereas the Mazda stuff is not. So if you've seen these discs before, they usually have a big harmonic dampener behind them. So basically we pissed that off, and I've machined the step down all the way enough so that we can get a bolt pattern through there and a nut on the back of it. That's going to allow us to use the bigger unis and achieve what we want to achieve, so it'd be a bit stronger. So our diff plates have been all finished and welded up. Our gussets are in. We went with urethane diff mount bushes instead, but as you can see, there's nothing supporting the diff at the front. So that's kind of a bit of a problem because our pinion angle should not be dynamic, it should be fixed. So what I came up with was a bit of an idea. It's a bit of a compromise and it's a work in progress, so just bear with me. It will receive some refinement. So normally these two bolt holes, and where this guy has a really nice collar, the power plant frame, otherwise known as the PPF, fixes to there and runs all the way down there to the gearbox. So that's on the standard setup. So obviously we don't have an attachment point for the PPF on our gearbox. Plus it's the wrong shape now. It would be nice to run the PPF, but whatever. So because we've got a really nice collar and we can use original bolts and stuff, I've taken this guy here, which usually bolts to the underneath of this, and as you can see, it fits rather nice, right? And I've welded a sleeve onto the side of it. So this sleeve is the right size to use our suspension bushes that we used in the front, which were, if you remember, they were originally Corolla trailing arm bushes. So what I've also gone and done is made a little bush on our small lathe here, and basically this guy goes up and sits on there, and you can see how snug it is. That collar is so nice, that locating collar. Now there is a really nice fixing point just here. It's hard to hold the camera and point your finger at the same time. So we've got a fixing hole there. So I've offset this from the center of this adapter so that it's in line with the bolt, and all we have to gonna do is jog across there. So what I've made is this mount. Now this is 8mm thick steel, right? So there were root welds done, and if you don't know what a root weld is, it's when there's a big V created and a core weld run to bond it. So I heated this up to about 600 degrees and then did a root weld and then cover welds on it. So they might look scungy now, but they are very, very, very strong. So it's welded completely through, it was heated up. So if I go and put this together, I'll show you how it goes together. So basically this plate fits over the top, and there's a bolt that goes into that mount, and then a bolt goes through the middle there onto our cross member. And this is what we end up with. So it's a nice neat solution, but it's not the final solution, because what's going to happen is this here is going to be linked to this bolt pattern here, right? But we're going to wait until the exhaust goes through to know how much we need to drop it. Now, thankfully let's get some light. Thankfully hang on, I'll come over here. Sorry, people. So thankfully we're right in the middle of the wheels here. So we have the most amount of clearance possible, and we'll be able to hang it slightly lower than we normally would, but the exhaust kind of needs to take priority. So we're gonna run the exhaust first and then weld to here and go directly over to that bolt hole. So we'll have a cross member that covers the entire frame, and then our frame will be braced back again. So the good thing about doing this is that we'll be able to put our original frame brace back on, which braces from this bolt to this bolt, and I think it's just here to the chassis, and then the same on the other side, from there back to there, and then back to there. So all that OEM stuff will be able to go back on. So that's a real good advantage. But what I'll do now is I'll put this all back together and show you the assembly when it's bolted up. Okay, so we're looking pretty sweet there, but what you might notice is there's an actual gap here where the mount goes on. So the way I've designed it is so that when we've got a bolt directly vertical, right, that's going to allow us to move our diff up and down and put different amount of shims in here to tune our pinion angle. So you might be thinking, but a pinion angle should be fixed, the pinion angle should be 0 to the box. Well, not necessarily, because we can tune the pinion angle to give us more, or less ideally, less traction. So what we're going to be able to do is set the pinion angle 0 to the output of the gearbox, and then adjust it slightly, probably to give us a little bit more pinion angle, to increase our traction, and then actually dial it in to suit this car, because some cars like more pinion angle than others. So that's the beauty of designing this system, and then we'll work on, like I said, later bracing it back to up here. So what I'm going to do now is have a bit of a go at the gearbox mount. So I'm going to have to make a bit of a jig and see if it's actually going to work. I've got some more tube here, and yeah, I'm just going to have a go at it and see if I can get the clearance I want. Because ideally now, if I wanted to put a piece of 3-inch through, it's going to come through here and basically hit the gearbox mount like that there. So it's not going to work too well. So all I have to do is go above this, where this tube is sitting now, and we should be golden, and we should be able to fit a 3-inch exhaust through there, which is ideally where we want to be. Okay, so here's the final product. If anyone's wondering why I put a small tube in a big tube, it's so that I could basically socket it in there and I can weld all the way around here, weld around all the way there, all the way around here and here. So you get a much stronger bond because you're relying on much more surface area weld. So it should give us the clearance that we want. Okay, so if we are to look at the lowest part of the car right now, which is the frame rail, and then this 3-inch exhaust still fits through there with heaps of room. So we can have a really, really low car, and keep in mind this is the part of the car that's most prone to hitting like speed bumps and stuff like that, because it's pretty much in the middle of the car. So the lowest line of the car, we can fit a 3-inch. We've got a little bit of room to spare, but basically I could also put a hanger off of here as well, which I might actually do. And so we can push a 3-inch like all the way in there. So we'll probably end up with a flange about here or so, or up further there, and then a flange back here. So it would make really a lot of sense if we were going to remove the gearbox or anything like that to have a flange about here, then a flange further up, then we could remove that whole section, and yeah, then we would be free to do whatever we want in the car. So there we go, that's sorted. Now I'm really happy with that. Okay, one of the things that needs to happen is the sump needs to be made. You might have seen a bunch of plastic on the bottom of the engine for quite some time. And then this flange, which has been bolted up. So we had this flange laser cut. If anyone wants the CAD file, we have a CAD file for it, and you can, we'll give it to you, and you can get your own sump cut if you really want to, sump plate. Anyway, so this is a bit of a challenging job, and I haven't exactly been putting it off. I've been waiting to do this. I've been throwing around a few ideas of how to go around it, and I think I've like basically got it sussed. So pretty much what we've got here is some pretty good clearance, right? And then we've got our oil pickup. So what I need to do is design the sump. I'm going to design the sump so it's got square edges coming off, and then design an oil pickup so it comes down here and then travels down the side there and travels to the back of here. So this is the massive amount of room we've got for a sump. We're still going to have within 100 milliliters of the original capacity, so I'm pretty happy with that. So pretty much what I'm going to do is run the sump straight up to about here, and then angle it down, and then come down all the way to the bottom of this cross member. So we're still going to have, you know, like maximum clearance, and I'm going to tuck it up a little bit so there's more likely to hit the chassis or the subframe than the sump, which is, you know, kind of the ideal way to do it, because you don't necessarily want to be smashing your sump too much. So yeah, I'm just going to throw this plate back in and start doing cardboard template. The wind is sort of picking up here. If you've seen this in the background and you're wondering what's going on with this, this is my car. It's a KP61 with a 4AG turbo, W58 Supra box, and Hilux rear end in it. I've got some more content coming on this car soon, because I'm doing some upgrades to the electronics to get speed sensing on the ECU, so I can do boost by gear and other cool things. It's a scary thing. Anyway, won't do as good at burnouts as the banana. But alright, so I'm just going to slide that plate in, and we'll go from there. I'm just going to use some CAD board and mark it out and make a template, because this is going to require the engine to come out to completely finish it off. So what I'm going to do now is just lay the foundation for the sump being done, So when this motor comes out the next time, which is probably going to be next episode, I'm pretty sure, we can finish off the sump, and I'll show you guys how I like to do a sump. This will probably be the 5th or 6th sump that I've made now, custom sump. So they're always a little bit challenging. They always have to get done differently to each other. So that's what we've got to deal with. All right, let's get it. Okay, you can see I've got a fair bit of room here. So I've just got to measure down to the cross member, which is, how are we doing there? Which is 57 millimeters, right? So I want 10 millimeter clearance to the subframe to allow for the engine sagging. So it means we can come down 47 millimeters from this flange down here, and we should clear everything. So when we go around the back, we are looking at from the flange to the bottom of the crossmember, 120 millimeters. So down here we can come pretty much like all the way down. So if I go all the way up, I've got 130 millimeters. All right, so what I want to do with it is I'm going to make a mark, which is probably going to be on the other side. And then I'm going to make a bit of a cardboard template and slide it in here, and this will be the start of the shape of our sump. Okay, so the first stage of this card here is just holding this up and just seeing how it sort of interacts with what's going on. So we can see that we've got a fair bit of room like up there that we can start with our incline. So basically what I'm going to do is to start chipping away at it and just make small cuts here and there. Put angles on here, and we'll see just how we go. I just got to chip away at it. So because what I'm going to do is make the sides and then make the bottom flat, I can definitely have a curve just here. So if we make a curve here, and a curve there, that will pretty much satisfy us. If we go something like this. All right, made some changes. You can put that in there. And that's pretty much what we're trying to achieve. But so now we're hitting here. So what we want to do is just line it up so that you can see that this guy here interacting with that. So we need to come, basically we want to follow this line down and we can come down from there. All right, so I made those changes and we're looking pretty good now, right? Although now, because you can see we've been making attempts at it, we're hitting here now. So this is going to need to curve in there, so we're going to need to take a bit more out, but we can simulate that by just moving it over, right? So I think there is about where we want to be as far as that goes. But now we've got this issue of like all here, so we're going to have to match up with that somehow. Okay, to template the bottom, the shape of the cross member, I'm just going to use this bit here and mark out the shape of the cross member for clearance. And what I'll do is I'll index it to here so that I know exactly where everything is, where the cross member is. And when I go to make the sump out of the car, I'll know exactly where the cross member is, and I can use this as an index point. But as you can see, making a sump is no real quick, easy thing. It has to be done like with a bit of care and attention and stuff. Okay, we're here in a very crowded boot to talk about power steering. You might be thinking, what the hell? But this is the original power steering system off the car. So this car originally had a BP 4W, I think, something like that, Mazda stuff. Anyway, so because of space restrictions, and we want to sort of free up a lot of room for our exhaust to run and things like that, we're doing away with mechanically driven hydraulic assisted pump. So what we're going to is one of these GM products, which is an electric over hydraulic power steering system. So basically what's going to happen is we're going to mount this. You can mount these anywhere in the vehicle you want. And then all you have to do is run a hydraulic line and then a return, right? So a pressure line and a return. And you can mount this pump anywhere. So we're going to mount it in this back corner here. And then what we're going to do is punch through the floor here and put some grommets in there. And we're going to run just braided lines from all the way from here underneath, as you can see, all the way the length of the car and up to the steering rack. And that'll provide us with power steering. Now, we'll only have to give it power, right, and a signal to operate, and that'll be us. We'll be all good. So just a quick little project is to mount this. So I'm going to cut all the mounts off of here and basically make an addition to this cradle, because it already is mounted pretty good. Like, it's on these little rubber things, so it should be very noisy. But I've got to lock all those legs off, and I'm just going to put some nutserts in here. So just going to make a little shelf cradle for it to sit on, and the pump can sort of live in there. It should work out pretty nice. All right, off with his legs. Now we got the bracket done, the bolt holes in. This should just slide straight in. Nice. Sorted. So when it comes to the front end, basically these lines are going to go sort of back how they went, and then so we'll get some hose over this side and reuse this pressure fitting, and then this return line I'll just bend that out and we'll run a flexible line like all the way to the back because it's low pressure. So I'm going to try and use steel lines to run the length of the car as much as we can, so that'll act as a power steering cooler.